All right, so we'll go ahead and get started. I want to thank everyone for joining us. Today we're going to discuss the SAP HANA on AWS QuickStart. My name's David Rocha. I'm a SUSE Public Cloud Solutions Architect. Really what that means is I work with our engineering team and our product team at SUSE and bring our products and introduce them into the AWS platform. And I'll let the other teams.
Brian Griffin, I'm a senior architect with our professional services practice, which is effectively our consulting wing for AWS.
I'm Naresh Pasumanthi, I'm part of the global solutions architect team for SAP on AWS. So I help customers, with their journey to AWS, so migrating to SAP workloads on AWS.
And in today's session, we're going to cover the SUSE AWS Alliance milestones. Discuss some of the things that we've done to work together to bring different products and services to both our customers. We're also going to discuss the SUSE Linux for SAP Applications benefits and how our customers are leveraging some of these features to really succeed on the AWS platform. We'll highlight what AWS is offering for SAP solutions, as well as demonstrate the SAP HANA on AWS, on AWS QuickStart. We'll also wrap up with a things to consider, just a couple of talking points on what we've seen to help customers kind of eliminate some of the issues. So a few of the milestones. SUSE has worked with AWS for almost 10 years. We were the first enterprise Linux distribution available on AWS, and that was offered in 2010. Since that time, there's been a lot of innovation, so we couldn't possibly put everything that we've done, and I'm only going to touch on a few. In 2015, we first made SUSE Linux Enterprise Server for SAP applications available on AWS. I'm going to shorten it moving forward for SLES for SAP, just so I don't stumble. But on 2015, we made that available, and shortly after that, AWS introduced the new X1, X1E EC2 instance types, which are 2 terabyte and 4 terabyte RAM type of instances. These were purposely built for SAP and targeted for SAP HANA workloads. So we definitely partnered with AWS in offering those instance types to our customers. In 2016, we introduced SUSE Linux Enterprise Server, SLES for SAP, on the marketplace. And what that did is we allowed customers to pay per minute for their subscription. Previously, you had to purchase SUSE subscriptions, bring them in, and register them. So we did make SLES for SAP available on the marketplace. Since then, there's been quite a few introductions as far as instance types. Recently, SLES for SAP is certified on the EC2 bare metal for HANA instances, as well as we've introduced SLES for SAP via an AISPL for India. So India has some regulations. We work with AWS to work through that so they can have those pay-as-you-go or on-demand images. 2 new offerings that have been announced at SUSECON are the SUSE Cloud Application Platform QuickStart, which is our cloud-native application platform that runs on Kubernetes. And what the QuickStart does is it allows you to deploy the cloud application platform and leverage Amazon EKS, which is their managed Kubernetes service. There's a lot of different sessions covering cloud application platform, and even one including that dives into what this architecture looks like. We've also made available SUSE Linux available on EC2 A1 instances. What this does is it brings a significant cost savings to customers who run these scale-out workloads. So if you have a number of web application servers or caching servers, customers are really starting to leverage that as a cost savings. The A1 instance difference is it uses an ARM processor as opposed to an Intel or AMD. So SUSE Linux is available to run on that. So we have a strong relationship with SAP, SUSE does, AWS as well. But if you look at what we're doing in the market, we have over 90% of SAP HANA deployments running on SLES or SUSE Linux. And what that does is it really illustrates the investment that SAP has and AWS and SUSE have made in engineering, SAP being able to support SAP HANA workloads on SLES. We offer 70% of, we run over 70% of SAP applications on Linux. So an SAP application can run on Windows or Linux, and if it's running on Linux, it's actually 70% of those workloads are running on SUSE. We power 100% of all SAP HANA on Power, or we run 100% of SAP HANA on Power, as well as Business One on SAP HANA. So if you look at what has really brought us to success is SUSE has a SUSE Public Cloud engineering team that works with the AWS team to ensure that all the services and features that are available on the Amazon platform or AWS platform is made available for SUSE Linux distributions. We also have architects that are residing in SAP Linux Lab along with AWS that collaborate to ensure that whatever HA solutions or whatever solutions we're putting together, we're working with the public cloud team and ensuring that it is supported on the AWS platform. And our solutions are optimized for AWS. As I said, we have a public cloud engineering team that really focuses and ensures that our distributions and our products take advantage of the AWS services. So if you look at how are you going to leverage, or how, if there's two ways to purchase SLES products on AWS. There's the marketplace, where it's kind of a pay-as-you-go, on-demand type. You pay by minute, and you also have BYOS, which gives you the ability to bring, for example, SUSE Cloud Application Platform, SUSE Manager, products like that where we don't offer it in the marketplace. You can bring your own subscription and launch it. One thing that does come with, or a few things, but one of the key differentiators from the on-demand versus the BYOS is the SUSE Public Cloud Update Infrastructure. SUSE maintains an update infrastructure for that on-demand images that publish repositories in every region available on AWS. And they are highly available, they are redundant. So what this means is if you're a customer deployed in Sydney, you're not pulling an update from Hong Kong. It's actually local. It's local to that AWS region. And what this means is you have fast updates. You're not, if you're performing these updates, it's all within that AWS environment. A recent change that was announced in January was the update for support lifecycle for SLES for SAP. Previously, we had an 18-month type of service pack for support, SPOS, right? So it's extended service pack overlap support. And you had a total 18-month life cycle, standard life cycle with that. What that meant was, at the end, after a release of a new service pack, you had 18 months. What SUSE did was they increased that to 4.5 years. We didn't want to drive updates or downtime for our customers, so we extended that service pack life cycle. And if you look at it, so we now have an 18-month standard and a 36-month SPOS with a total of 4.5 years of support. And as I said, we really don't want to drive updates and downtime for our customers. And if you compare this to SLES, there's a huge advantage. So if we're looking at SLES server SP3, at the bottom, it has a 6-month standard support. The general support ends on the 30th of June, 2019. And if you were to compare that to SLES for SAP SP3, you now have support through the June 30th, 2022. And there's not an additional cost. This price is included. So it really allows a customer to kind of dictate that upgrade lifecycle. We've also, in late 2017, streamlined the support model for our SAP customers. As I said, we've launched SLES in 2010, and AWS was a seller of record. So if you were running SLES and you contacted AWS, you would engage with their support team and they can offer support. When we first introduced SLES for SAP in the marketplace, that was in 2016, we used a company called Orbitera, which was a reseller. So there was a warm handoff to SUSE support. Now, Orbitera wasn't necessarily a support organization, so working with AWS, we sought to address that. And in 2017, we announced that AWS can be a seller of record in the marketplace for SLES for SAP. And what this means is you now have that streamlined support. So if you're using a support contract through AWS, you can contact them for SLES for SAP and they're able to resolve those issues. We have over 9 years of joint engineering experience. AWS is trusted for mission critical workloads. I mean, they work with Fortune 50 companies, and you'll see in a future slide, these are enterprise customers running enterprise workloads. And of course, a lot of them are powered by SUSE. So we're definitely working with AWS to run those workloads on SUSE. And we have a seamless joint support from AWS. We train the AWS support engineers on our products. So if there's SLES for SAP issues, they're highly skilled, highly trained support engineers. And with that, I'll transfer it over to the AWS team.
Perfect. Thanks, David. Awesome. So before we hop into kind of what the Quick Start is and how we get to the capability of deploying a certified HANA instance, a half an hour, let's talk a little bit about how we got there. So SAP started off as a customer of ours in 2008, and then 2011 we formed the official joint partnership. And right after that, we started the path as, I guess, to break a fair amount of new glass. We were the first cloud provider to go through and start doing this certification platform. So that brought with it some interesting aspects. But once we started going through and certifying, specific products from SAP, we started, onboarding smaller customers or smaller workloads, because at the time our engineering was at a certain level. And the seminal moment for, I guess I would say, our SAP practice was right around 2016. We had significant significant customer base, but it was limited to, I think at the time it was 244 gig of main mem and then 32 vCPU. So you could only run so much. But when we came out with the X1 platform, where all of a sudden we had 132 vCPU server with 2 terabytes of main memory, that really unlocked the doors specifically for HANA type workloads to allow large enterprise customers to start, I guess, moving workloads, testing those, and if it worked out really well, then they could go through and continue on their journey. And if it didn't, it's the cloud. You can go through and shut it down and try a brand new experiment. And in the typical AWS fashion, we very quickly iterated to take what was initially a 2 terabyte node with a 14 terabyte scale out to scale out to about, I think it was 50 terabytes. And then very quickly after that, launched the X1E, which had 4 terabytes of main memory. Now, why does that matter for you as a customer? Well, about 90% of the world's HANA deployments at that particular time were all under 4 terabytes. So that addressed a fair amount of the market. We already had public references, which you'll kind of see here, that had gone on that journey and said, we're live and productive. But we weren't here just to serve, you know, the 90%. Our mission is to go through and serve the world's largest SAP customers. And in order to do that, we needed to go through and provide a roadmap to those customers that we're going to grow with them, that we're going to provide some sort of runway for them so that when their growth exceeded that, you know, 4 terabyte single instance size, that we could go through and provide that. So we made a promise to the market to come out with a 12 terabyte instance, and that was actually announced last year for us to go through and do that. So it actually came in 6, 9, and 12 terabytes. And what we've seen happen along the way is that not only customers saw that promise come to life, but we also had partners like SAP start building some of their own products on us, things like SCP run on AWS, things like HANA Enterprise Cloud. We're the first cloud provider for SAP, first hyperscaler that SAP ran HANA Enterprise Cloud on, and it's really unlocked a lot of other SAP innovations for them to go through, and they leaned in with us. Things like NS2 and SuccessFactors, Concur, all of those things in some way run on the AWS backbone. So I think probably every company has their own version of this NASCAR slide, right? It has all of the different, you know, logos. What I'd challenge you to do is to take a look at the type of customers that are up there and also the industries that they're in. These are, you know, enterprise customers. They are things like oil and gas with BP, things like Bristol-Myers Squibb in healthcare life sciences, in aerospace and defense, Lockheed Martin, insurance, you have AIG, you have Liberty Mutual, right? These are really, really large workloads for really, really large companies. I was at Sapphire last year presenting with Cardinal Health, Fortune 15 company, talking about a validated workload that we are running on SUSE. We were talking about the high availability capabilities and how they've really, really helped have their uptime increased. So regardless of what industry you're in, AWS has not only the certifications to go through and say we can go and run that particular workload, but you also have peers in that particular industry that you can go and run your questions by them. So I know SAP is very much that type of industry where you want to go through and see who else is doing that. You don't want to necessarily be the very, very first. And we're absolutely at that point now. I think we have I think it's over 1,000 customers running SAP on AWS, and over 100 of those are what we consider enterprise customers. So with the AWS platform, you have a myriad of options, myriad of instance families. These actually aren't even all of the different instance families that we have, but some of those are more for web workloads or something outside of SAP. And what we do is we are pretty prescriptive on the type of workloads that you can, or the type of instance types you should be running SAP on. That doesn't limit your options, as you'll see in the next slide, but it gives you an idea of what the capabilities are. And what we do is we benchmark those. We have our support engineers that work with SAP and SUSE to go and do these benchmarks. And what they do is they provide you a very clear estimation of how you size a system to exactly what you're supposed to, what it's supposed to be, and if you need to go through an upsize, here are the ways you can go through and do that. One thing I like about this slide is it talks a little bit about this thought of constant innovation. I think when I started in 2015, we were on the R3 instance family. And with the way all of these works, you start off with an M4, and then that transitions, and you have a new family that's an M5. And the same thing, C4 turns to C, or we have C4s and C5s, and R3, R4, R5. Well, great example, in the R3 family, even though it had the same amount of CPU and RAM that were associated with it, when we came out with the R4, we had a brand new chipset. And what happened, which is also very common for AWS, is when we launched the R4, we had a 20% price decrease. Now, because we also had a chipset increase, that was actually a 20% faster SAPs per CPU. So you had a huge swing there in what you were getting dollar for dollar versus what you'd had the day before. And Same type of situation happened when we launched R5 just last year. The price stayed exactly the same, but you got 11% more performance for that exact same CPU and RAM configuration. And unlike most places, to swap an instance type from place to place, it literally is a stop the instance, change the instance type to what you want, and start the instance. So you're completely changing the engine that is powering everything. And as a result, instead of doing hardware refresh cycles as a project or something that takes a significant amount of time and planning, this is something you can do with very, very minimal downtime. If you are rolling through your SAP, if you're taking SAP servers out of the logon groups and you're using something like SUSE HAE to do controlled failover in the cluster, you can do this without any downtime. SAP projects and SAP landscapes are complex enough. When you go through a server refresh cycle, utilize AWS to do it, and as a byproduct, not only will things go through and get faster, quite often they'll go through and get cheaper. That's not hyperbole. AWS has lowered the prices 70 times in the past 10 years. So this is something that's kind of built into the DNA, and what ends up, when we continue to grow our scale, we pass those cost breaks on to customers. So I won't dive into this. This is just the whole chart of the very latest instance family. This is all to say you have a lot of choices. You don't have a few servers to choose from. These are the latest instance families. They don't have any of the 4 series or the 3 series, which, by the way, you could still use. But you have everything from a server that has less than 3,000 SAPs to a server that has nearly 500,000 SAPs. So no matter what your instance type, what your workload preference is, we most likely have an instance type that is going to go through and fit that. And that's a key piece for moving to the cloud, because what we see typically in on-prem deployments is that your capability of sizing workload exactly for what you need was not there. You had to go through and plan for peak, or you had to go and add a significant amount of addition, because the penalty for being wrong was that you couldn't run your application. There's a huge benefit by moving to AWS in the sense that you can really, really right-size your workload. And as we mentioned in kind of the last slide, you can do that for a particular day or hour or week. So I'm on a Fortune 50 customer right now. And just last week, they're using S4, doing CFIN loads. This is a one-time load activity. This load activity is going through and taking between 12 and 24 hours every single time they go through and do it. And they're using these M5 2x larges. What do? We stop the instance type. We change it to an M5 24x large, crushed through that workload in less than an hour, swapped it back down to an M5 2x large for those application servers, and that cost the project a grand total of less than $30 to go and do that. Now, can you imagine the number of consultants that were on that? From a basis perspective, from the S4 functional perspective, from the SAP perspective, it was a huge, huge cost savings. And this is just something we do every day. This is the power, the benefit of I guess infrastructure as code and the capabilities to be hot plug interchangeable. So I touched briefly on this in a previous slide, but there was something that happened last year to kind of enable this 6, 9, and 12 terabyte instances, and that was the Nitro technology, or the Nitro hypervisor. Previously, and actually still a fair amount of AWS runs on very happily on a Zen hypervisor, and that's great. But we knew if we needed to go and have these massive instances, that we needed to have something that really felt like bare metal. And the Nitro technology was the way that we went through and did that. So right now, we have available the 6, 9, and 12. In 2019, we're going to have 18 terabytes and 24 terabytes. And again, these are single node. This is all scale up. We also have capability to go through and scale out. So that whole concept of just serving that 90%, now we truly are serving the world's largest customers, and innovation doesn't stop here. I think the most important part, though, before there's an arms race of who has the biggest server or whatever, that is all well and good. For sure, there is a table stakes, minimum table stakes you need to play at this level, and size is absolutely one of them. But the way you go about implementing this technology is also a piece that's not super transparent to everyone. And what I mean by that is all of these things on the left-hand side kind of talk about how this Nitro technology and how it interfaces with our existing infrastructure is really, really important. And the reason why it's important is because these beasts of machines, they're sitting right next to everything else in the AWS fabric. So it's in the exact same data centers. It's using the exact same API calls. It is using, it's all contained within a simple VPC. It's all using everything about the cloud that you love and use. It can use those as well. So even though these are purpose-built machines, they are not a machine that's been stuck in a co-location facility and then, you know, in a separate data center that you have to hook a big fat pipe up into and then run some sort of hybrid workload where app servers sit over here and your database sits over here. It could have been very easy for AWS to go down that route. There are other places that go through and go down that route, and we do not because we didn't think that was right for the customer. So what we did is we delayed it a little longer, and now we have it so everything sits in the same spot. And it's really, really important because when you're talking about things like HANA system replication to different regions or for high availability, those things, those networking items are really important because they will break in the other scenario. In this scenario, they are absolutely 100% native. And the big benefit here, obviously, is latency as well. Latency to go across an MPLS connection, that is not something you're dealing with in this type of scenario. And that is it.
Thanks, Brian. So what you've seen till now, what Brian has shared, is more about how we innovate and how we help SAP customers by releasing new instance types that are both certified for SAP and that meets customers' requirements, right? So when it came to HANA, one of the most important thing was where we started giving this even as though it's small, but it was the largest instance in those days, are a 1/4 terabyte memory instances, right? When we gave these instances out to these customers and said, hey, we gave them a guide to how to put them together and then run a HANA workload. What happened is we have actually seen customers actually doing some mistakes in terms of how the storage is configured, how the kernel was configured, or various things. There are many things that need to be done right to have the best performance that SAP guarantees, right? So what we have done is, we do certification process, we do an extensive process with that, and we know how these systems need to be configured. So what we embarked on is something like what we started doing is, build quick starts. So the word quick start is basically, quickly, spin up, take an EC2 instance or everything else that is needed for from a services perspective, like the storage, the compute, and networking. Put them all together, stitch them together in an SAP AWS best practices way, and give access to that instance so that customers can deploy a SAP HANA software on it and run with an assurance that it is going to work and give the best performance, right? So SAP HANA Quick Starts allows us to follow a virtual appliance delivery model. Like if you have to do an HANA deployment on-prem, the thing is either you have to do an appliance or you have to go with the TDI, which is an expensive process. So look at this as an analogous to TDI, but it is completely infrastructure as a code. So within like less than 30 minutes, you'll be getting an HANA system that's completely configured, and in fact even HANA software deployed on top of it, right? On the back end and the foundations of this is AWS CloudFormation. We use that, we script it up, and then do everything that's needed for HANA system. It comes with SAP AWS best practice and also SUSE, and I'll talk about that in a minute. Okay. What did I do? Okay. So before, Brian was alluding to this quite a bit, right? That it is so quick to spin up something, scale up, scale out, right? And if I look at my journey, where I was a basis consultant for about 15 years before I joined AWS, and then if someone told me before I came to AWS that hey, you can spin up an instance in such a short amount of time, including something sophisticated like HANA, or even scale up, I wouldn't just believe. I would basically think that it's a myth, right? And one of the ways that I actually try to make it real is by showing a demo. So let's actually go through what a QuickStart is, how do you find it, how do you find QuickStart, and how do you actually launch a QuickStart, and what it actually looks like. For someone who's really new to this foundation of CloudFormation or even infrastructure as a code in SAP domain, which is not unusual even today. Let us go through a quick thing. So when you just go and then click search for SAP HANA, AWS SAP HANA QuickStart, right? You just Google it up, you'll see this QuickStart page come up, and then you just click on it, and it probably came on the top just because I do that quite a bit. But you obviously find it right there. So this is the landing page where you can actually find the QuickStart, and this is a reference deployment. There's a lot of documentation out here, and it gives you how to deploy. There's nice pictures, and I will come to these pictures in a minute. If you go to how to deploy section, you actually can look at how the deployment patterns that we support. I'll talk about that in a second. And then you can do it in a new VPC or existing VPC. So VPC is virtual private cloud. So basically you get the ability to build your own data center in the cloud using in AWS using VPC. So you define your IP range, and you say that, hey, these are the public subnets, these are the private subnets, and I want to deploy my mission critical workloads like HANA in a private subnet. So you have that complete control on who can access, what kind of communication can go in and out. So let's actually pick something like a very simple one, which is a single easy deployment into an existing VPC. What it's doing is actually it is loading up because I'm already signed into my console. This is the script. You have access to the script. You can take it, you can adapt it like what you want. Like say example, we do 10 things, but you want a couple more things to be done. Like example, joining to your domain or something like that. You can go to this and change the script. So when I click on next, it gives me a bunch of inputs that I need to enter. So I'm just giving it a name. And then here are all the inputs that are relevant for an SAP HANA deployment. So I'm just picking up which VPC I need to put it in. This is basically telling, hey, I want to put this in this VPC under this private subnet, so it is only accessible to my basis folks, my other applications that are running with the same enterprise applications like SAP, like application servers or whatnot, right? And then, so we also have an ability with QuickStart to deploy RDP, and I'll talk about that in a minute. I'm not going to deploy this in this one, but I'm just going to pick it up here. Is a public subnet. Okay, this is my public subnet for this, and I'll just copy these from here. I just didn't want a typo here. You might do this every day, but sometimes demos is when it actually fails, right? So as you see here, we support almost every SUSE operating system that is supported for SAP and AWS for HANA. You can pick which one, and David went through different slash standard and slash for SAP. I'm just picking up this for this use case, and we can support single instance as well as a distributed, like in terms of, in case of OLAP where you have BW workloads, you can have scale out deployments. So you can even actually do scale out deployments with this. It's not just single instance deployment, scale out deployments also. I'll talk about dedicated host in a second, and then these are some other like a key pair. This is what you use to log into the instance. These are the storage types that I'm using. We have GP2 and IO1. GPT is good for fairly good amount of customers that we see, and if a customer needs even a higher performance, then they can go to IO1, and I'll talk about these two flavors in a minute. And this is where you're actually giving HANA database specific requirements. Probably this is something that's very familiar with you guys. It's basically saying that, hey, what name should I give to this server, right? I can give this one. This is the master server, and then I give it a worker. I'm not using a worker in this case. I'll just leave it because I'm only deploying one node. And this is my SID for database, and this is a password for HANA database. So once we deploy it, hopefully, and this takes about 30 minutes probably. If you stay there for 5 more minutes, I can show you that it is finished.
Does it put that on the system user?
Actually, I'll tell you one more thing. It does. You have a new HANA system that is new EC2 instance that is taken up, configured, and HDB as a HANA system that's deployed on top of it, right? So if you see here, I can also give access. I can also host my software in an S3 bucket and give access to that software here. So I'm just picking up my URL from there. Okay, and I'll just show you. So this is S3, and this is how the software looks. These are standard ones. I think you are very familiar with this. There's three archives that you get from SAP. You host them there, and you provide the link out here. That's it, right? And if when you select yes, HANA software is deployed along with it. It is not just the instance that is configured, but HANA software is deployed with it, right? So these were the optional configurations. We don't have to go into this deep, but let's say you are just getting into AWS platform. You as a user want to just test it out, see how all this works. You can actually deploy an RDP machine with it. So you can, instead of going to HANA system, you cannot get into the HANA system directly because it's a private subnet, but you can have an RDP system which is available over the internet. You can log in there and then from there access the HANA system in the backend, right? A little more security. I don't see an enterprise customer deploying this, as an, when they're deploying their workloads, but usually it will be the test cases, POCs, where they would do this, right? Rest everything is something that we don't have to go through now. And then you just click next, and then accept and acknowledge this. There's a nice confirmation page that gives you like everything that you have selected here. And then you set create, and then it starts creating this one, okay? Hopefully things work. There are times where just because of the demo, this demo, if I pick some option wrong, it might fail, but hopefully it doesn't. Let's see. This takes about 35 minutes to do it. So if you are having an VPC subnet already created, the reason is even we could, as you saw in my QuickStart page here, you could actually even create a new VPC along with HANA system. So you won't create a VPC for every time, right? You'll create a VPC subnet infrastructure and you'll deploy HANA systems, how many ever you want within those constructs. Generally, that is a more an infrastructure security architecture or decisions which take a little longer. So once they are in place, to deploy a critical application like HANA in your environment, in your AWS environment, this is the amount of time it takes. Though it takes 35 minutes to finish, I don't know, I probably would have spent about 5 minutes, and that's what I'm explaining, right? And you can shrink it down, you can default some of these parameters, and then that way you don't have to select all the parameters, you just probably select the SID, system number. That's it. Everything else is standard, right? What changes from one HANA to other HANA system when they're sitting in the same VPC, right? So that's what it is. This is the experience that you as a customer will get when you're doing it when you're doing HANA deployment on AWS, right?
Did you guys publish the changes that you're making to the OS as part of your QuickStart deployment? What you're doing throughout the last?
So there is a AWS and SUSE best practice guide that is published, and one of the things to consider at the end is, it definitely describes, what the VPC is, the fencing agents, how they work, the policies that are set up. So it's if you were to go through it manually, there's a lot of steps. So the QuickStart really helps automate that. But it's key that you understand everything that's going on in the event that you need to troubleshoot and test. So we do have that best practice guide outlined with all of the settings that are set up and automated.
Yeah, it depends to what operating system. Yeah, so what operating system you choose, whether it's SLES for SAP or regular SLES. So there's a page out there which goes through and tells you the requirements to run an SAP HANA on a SLES server. And for SLES for SAP has, SAP Conf and some other configuration pieces where SAP Tune, right? So I think now, depending on what version you're on, a SAP Conf or SAP Tune or a combination of them both, but you can go through right now and if it's on SLES for SAP, then that gets auto-called in the QuickStart. So it'll set all those parameters for you according to that particular node, according to SAP Conf, and if it is, or SAP Tune, if it is standard SLES, then we actually hard code those particular items in. So you absolutely can see it. In the documentation, I think we list a number of them, but I think really more what we do is we point to the note, like these are the OS requirements that we looked at to do this. Like we turned off AutoNuma, and we turned off huge pages and all of those other OS specific configurations, because most of the time installing HANA isn't that hard. What is hard is configuring the infrastructure and the operating system to match all of those specific requirements. And it is a lot to go through and do, and then to do it consistently across your entire environment is quite a thing. So this is hugely beneficial in that standpoint, and it also gives you the capability to stand something up for just a minute or, well, for an hour, take a backup from something else and have it totally walled off, test it, see if you want to go through and patch your HANA database in a certain way. Let's say you're trying to understand how the patches work and you don't want to blow up your sandbox system or dev system. You go through and you run that on, you know, this thing that's been an hour, you get it working, you blow it away, and you've paid just for that hour of particular infrastructure. But by using the quick start, that stand-up time, I mean, you enter the parameters, you go get a cup of coffee, and then you can start your testing. It's pretty useful.
Is it the same price for quick start versus?
So actually QuickStart is there's no cost to QuickStart. There's no price for QuickStart. We build this code and we give it to you, so you can even extend it. There's no proprietorship. It's open source, if for lack of a better word. The only thing that you'll charge is the infrastructure that it spins up, like the EC2 instance, the EBS volumes, or whatnot that it creates in the backend, right? That's the only thing that you're going to charge. So while that is getting launched, let me go through a couple more details about the quick starts, right? What we launched now is a single node architecture where you have an HANA system that is built. It has all the volumes that are related to that that are needed for this HANA system, and I didn't select this, but this was what I was telling you, that you can also create a public subnet and create RDP machine. So if you are just testing in a POC, so you can go from a public internet into the RDP machine and then access the backend HANA system, right? But generally what we see is customers, and as they evolve beyond a POC, don't bother about this, right? But they only build something like HANA systems, like it might be 1, 10, or 15 based on what their requirement is, right? And then when you talk about BW, still scale out is something that customers do deploy, and HANA, the quick starts, we have within the quick starts I showed you where we had a number of worker nodes and a worker node naming convention. So you can say, like, I want to deploy 10 of them. What it does is it takes 1 master and 9 of them as workers. And what is the naming convention you gave for worker, it will append a 0, 1, 0, 2, 0, up to 0, 9 for it. So that's how the naming convention is brought up, and you have like a total of 10 nodes, 1 master and 9 worker nodes for it, right? I would also like to tell you that in AWS, we don't follow anything like a standby node. Okay, we have something called auto recovery on top of it, but we say master and worker nodes for this one, right?
So if you look at that inside of the HANA Studio, you're just going to see all of them as worker nodes.
Yes, all of them as worker nodes. Yes, that's exactly right. Right, and then this is also something very unique with I picked / standard there, but if you pick / for SAP, you could even deploy something called HA configuration, and that is what we are showing here, right? This is a multi-node architecture, and what you're seeing on the left is one availability zone, the right is other availability zone. So when the best practices or the recommendation from AWS is always to spread your high availability architecture, the primary and secondary, across 2 different availability zones. So these are a cluster of data centers by themselves. They're completely redundant from the power that is being sourced to it, they're in different floodplains and all of that, right? So you get a very high degree of high availability just from the infrastructure layer. And then on top of that, by spreading your HANA primary and secondary across 2 availability zones, your application is now very highly available, actually all the ground up from infrastructure to the application, and SUSE HAE takes care of monitoring and then doing the failover and all of that. So even that you can actually deploy using a quick start. The same scenario, the same experience that you have done, that we have gone through, same thing. You just use a different template that was there in the same page, and then you basically say that, yes, I want to deploy SUSE HAE, right? And we can automate that. So this is all the quick starts that we support for HANA deployment. Apart from this, there are several other quick starts that can help customers beyond SAP, and even there's a NetWeaver quick start that helps you to even automate your NetWeaver layer.
What kind of monitoring do you guys provide for these kind of environments? Is there a built-in product you guys are setting up, so like if my instance fails over, I know that?
Sure. So when you're talking about this kind of architecture where you have /HAE deployed, /HAE, the configuration of /HAE takes care of monitoring that the application is up and failing out to the second one. So it's part of this /HAE.
But how do I know? Is there something that you guys are notifying me that I have fell over in my environment?
Yeah, you certainly can. so you can do it via SNS. You also can configure HAE to send you an email whenever a configuration event happens. So it depends on how you want to be alerted, but absolutely, we go through and do that. Or we can. It's not, I don't think out of the box, out of the quick start. You can see that an instance went down, but I mean, if you configure an SNS notification, it's like a 5-minute task to go and do, you get alerted. What I usually do is I put a configuration item on the IP address. So when I see the IP address swung from one place to another, then I know, and I get an email myself that's saying, hey, this particular thing happened, and that's like a really good indicator that HA kicked in.
Now, when something like that occurs, is your default to leave the failed node down and bring it up on the other node, and then
you can have
somebody would go like that?
yeah, yes. So you'll have to. The best practice is always about go look at what's happening and then go to the root cause of that, and then bring this up as a secondary, and then let it sync up and then fail over if you want, or you can keep it running that way because of the way the network is set up, right? You don't have to absolutely fail back and make it something. There's no reason why you cannot make that as primary, right? As long as your application servers are distributed and all of that, right? Yeah.
Just a comment, if you decide to use /HAE to automatically fail over your cluster, then you can use our auditing software, CloudTrail, which is pretty much monitoring any change in your VPC. And if CloudTrail is enabled, you're going to see log entry like node A has been shutting down node B. So you know why node B went down. It got shut down by node A.
And you can put some notifications on top of the CloudTrail APIs, because it is an API call, and you can say that, hey, when this API call happens, get me notified. You can do. There's multiple ways to do that. And 2 ways we discussed about it, right? Sorry. So one other important element is, I did mention about QuickStart being, taking the right instance type that you want, as well as, in our case, we picked up an R3 for 8x large, which is a 1/4 terabyte memory. The other thing that goes along, important element that goes with HANA is the storage sizing, so that you get enough throughput from as per SAP specs, right? So when you pick up an instance size in our when I was running the QuickStart, I never picked, hey, what kind of files, how big a file system I want. I only picked what kind of file system I want, right? I only picked GP2 as a file system type, but I didn't say like, hey, I wanted a 1 terabyte file system or a 2 terabyte file system, right? Because what we're doing in the backend is based on based on our certification experience and what we have worked with SAP. We know that if you have a 2 terabyte HANA system, this is the minimum storage requirement that requirements that you need to meet SAP's benchmarking process. So with that, if you go to our website, you have for each and every instance what is the volumes that we are provisioning, but you can see this as an indication to what we provide for a 2 terabyte instance. What you're seeing is here is the data volumes being created with 3 800 gig volumes, providing a 480 Mbps of throughput, and the total IOPS you see there, right? And then you can also, if in my options I picked as GP2, but if you picked as IO1, you'll get this kind of a configuration. So we do that mapping based on the memory, based on the instance that you pick, based on the memory.
You guys are making the calculation.
Exactly, we're making the calculations, right? We're making the calculation. So most of the times, we have seen, I don't think we have seen a customer who went away from this kind of a recommendation,
right,
or I needed to go. I would say based on the experience that we have, but this is a starting point, we always say.
Yeah, and by the way, that in typical AWS fashion, like that combined throughput number is no longer accurate. I just saw that now. We went through and had an update to GP2. Your GP2 throughput used to be 120 meg per second, and now it's 250. So when you strike those, that's going to be 750 combined megabits megabits a second. So it's a very normal thing. And what's really cool about this is, if that changes your architecture, the next CloudFormation template that you go through and do, you just modify that particular, there's a storage parameter item on there. So instead of saying 2, you put in, or instead of saying 3, you put in 2. It's a quick math calculation, or you can go through and just live with a higher combined throughput. Yeah. But again, no price increase in that situation.
Yeah. And generally we catch up. So with the quick starts, we are evolving. We update the quick starts very often. So let's say because the EBS now provides more throughput, we don't need 3 volumes, and we'll optimize that. Whatever is needed, we go back and do it, right? So these are the HANA data and log volume sizing, but there are non-database areas in HANA. This is the file system. So this would be same for irrespective of the instance size. This would change based on the instance size that you're picking up. Okay. So moving on. So Brian also alluded to scaling up and how easy it is to scale up and all of that, right? So and also he mentioned about the high memory instances that we have. These are like 6, 9, and 12 terabyte systems. These are bare metal instances, right? But these bare metal instances, as Brian was saying earlier, these are completely integrated to the fabric. And what I mean by that is, the same way you interact with any other EC2 instance, whether it's like a T2 micro, which has like not even one full CPU, but a variable CPU assigned and 2 gigs or 4 gigs of memory, whatever that is. I don't have it on top of my head, right? The experience that you have is the same thing that you'll have with a 12 terabyte instance. So you go to the console, you launch the instance the way you launch it. The same thing it is, right? So yes, I can go to the console and I can do the same stuff, right? But one thing I really like is the 165 plus services that we have, and how you can use to in an operational way to manage your SAP landscapes. So I've done a quick demo and a disclaimer that I don't assume that anybody in this one or anybody in the world will actually use some kind of an automation like this, but this is just to show you the power of the platform. And what it is doing is, I have an Alexa skill that is built to actually do what I want to do, right? So I can go build a script and then execute the script by showing you a black and white screen in Linux. But I prefer to do this. Alexa, what's the date?
Today is Wednesday, April 3rd.
Good, so it is working. So let me actually make it do some work for me, right? Alexa, ask Elastic Compute to scale up HANA to 12 terabyte. Hopefully it works.
HANA instance resized to 12 terabyte has been initiated. We will notify you once it's complete.
So this was actually a 2 terabyte instance that was running, and this was running on a 2 terabyte before. So in another 10 minutes actually, right? Think about the 10 minutes. That's a very important element, right? My laptop sometimes takes more than 5 to 6 minutes to boot up. Okay, that's a very important element, right? And here I'm talking about a HANA instance, which is a 12 terabyte instance, booting up, and a HANA instance running in about 10 to 12 minutes, right? There are some more information that David is going to share. Once he's done, I'll come back and I'll show this, and hopefully even the other HANA. Sometimes it takes about 30 plus minutes for the quick start to finish, but sometimes it might be finished in like 20, 25 minutes based on how some steps perform. So we might even see that happening, but we'll come back and I'll show you this one once I'm done. I'll move this off.
All right, I'll just hold this. So just want to point out that there's a couple of things to consider whenever you're deploying. We've encountered customers who have used the Quick Start, launched it, it works fine, but as I said, we do publish AWS best practices. So when you're talking about the different resource agents that SUSE provides to run these SAP workloads, or the fencing agent for AWS, the AWS and SUSE best practice guide really go through and define what that policy is. The best way to go to the best practice documentation is the SUSE.com documentation, and then you'll see SUSE Linux Enterprise Server for SAP. Select the version you're at and go to best practice. It is updated frequently, in the past couple of months there's been an update in December. So just look at the date. If you bookmark it, you have a chance of it doesn't refresh it. So always go to the documentation and get the next one, because what you're doing is you're bookmarking that best practice guide. So if there's any changes or updates made to it, you're still referring to the old version. Also, if you're encountering an issue, look at what's causing that issue and see if there's any updates available for that package. And we've encountered this with our support team, that if you patch that, if you have a test environment, you can reproduce it, perform an update on that package, whatever that package is, and you know, more than likely it solves 80% of those issues. Also, don't use support products that are end of life. So and we encountered this, luckily, you know, our product team and SUSE realized that the customers needed a longer life cycle for SLES for SAP. So if you remember back to the previous slides, it was 18 months. We've increased that to 4.5 years, but it still shouldn't stop you. You know, at a 4-year mark, you should have already probably moved off that service pack. You know, what we're doing is we're extending it to allow our customers to adapt and adopt the new technology, but not to really run up to that end and then be in the same predicament. So always look at when that support ends for that product, and be sure that you're taking advantage of the next update. So really isn't a lot of time. Do we want to open it up for questions?
Yeah, we will take some questions and then I'll
yeah.
check in the meanwhile.
Just one point, because I don't spend a lot of time doing presentations. I spend most of my time with customers in the field, and it was not lip service when we say like there's a warm handoff support between SUSE engineering and AWS. I'd say like 3-4 weeks ago, we encountered a particular bug that was only happening in the SLES 12 SV2 for one of the IP address moves from place to place. It was a very like an edge case scenario. We opened up a ticket with support, and within a week had that bug pushed to, or the correction pushed to the main line, so we could go through and correct that particular package. And that was the speed at which that happened was really, really strong. So it started off as AWS support case. We also opened it up with SAP. They both ended up with SUSE, and we were able to prove that. Very quickly had an update. And if you're used to the SAP world, it doesn't happen very often. If you open up a message with SAP that there's an issue, and instantly you have like an S note that's pushed to you. So it was a very pleasant surprise.
Is the version of Slice typically the GA version that when you're choosing that, or yeah? So then you'd have to apply any updates to that, or?
No. So like for high availability specifically, you can just update the pattern for it. You can update the individual package itself if you happen to know it was with the AWS move VPC IP or IP VPC. Or you could just say, I want to take everything in HA software or HA package, and just update that. So that'll bring in updates to Hawk and CoreSync and whatever else. Yeah, so you could be as, or you could just do a standard zipper up and just do everything.
Any other questions before we? Are you going to take a look at it first?
Yeah, I'm looking at it. It's still running. I think this one will take about 5-10 minutes more. They should be done in another 5 minutes, I think. The resize itself. Yeah. But essentially, you know, I can go through the process, what the resize is doing, and I think this is what Brian was alluding earlier. So this is an HANA system that we built, and this is running on R4 8X large, and the configuration of the HANA system itself is happening right now. That is a file system, the deployment of HANA software, all of that is happening right now. So that's what it is. So let's say if this was already running and then you wanted to scale this differently. So basically what you do is you go to the stock instance, right? And then you go to change instance setting, and then you say the change instance type, which is not highlighted now because the instance is running. Okay, and after that you go back and start the instances, right? So this is almost the same process that you do for scaling up or down. Okay, and let's say you have an R4 instance now, which is what I'm running right now, but you want to now change to R5 because it was released, right? That's exactly same experience that you'll do, like shut this down, start it on R5 instances. So this is more like now we are adopting, new technology, new innovation, new processor type, and whatever comes with R5, which is better than obviously the previous version. So you're doing that. This is similar to what you would have done, like 6 months planning for buying, racking, stacking, planning for an hardware refresh for SAP systems. So which you could do like in a matter of minutes when you think that you want to do it, rather than building up that big project to do all that, right? So you can, let's say, if you think that that is something that you want to do today, you can do it just now by planning the outage. Obviously, there are always, from change management perspective, basis perspective, you have to plan the activities. That's the operational part of it. From a technology perspective, it's pretty quick.
Naresh, since you're talking about dynamic changes, we see a kind of 3, 4, 5 times a year customers in sub-support who have HANA subsystems which are too small. For which reason ever, are ignorant, stupidity, not reading manuals. And the beauty here is we can migrate these IO subsystems on the fly with HANA up and running to a different type. We can move from GP2 to I1, or we can increase the number of IOs we assign to such an IO subsystem. And these HANA performance tickets typically get solved like this, by simply asking the customer to migrate to a different IO type, or to increase the number of IOs per second. This is really sweet and it's super flexible. Customers in the on-premise world have significantly bigger problems to live.
Yeah, that's great. And this one just finished, the deployment itself for HANA finished. You see this, so this was the HANA system HDB that we deployed, and you see here that it is running on a 1/4 terabyte memory, right? And everything was done within the presentation that we did, all the talking that we did, all the noise that we did, and we were able to deploy this server. I wouldn't say this would be the experience, the first instance that you deploy, just because of various combinations, right? It would be like your enterprise architect would have put from a networking perspective that I don't want to do this, I don't want to allow this, I don't want, or it wouldn't, the VPC structure or the subnet structure would not be ideal to adopt something like this. But once you get the hurdle of deploying the first system, whether it's half a day or 1 day, right, which is typically the max you see, if everybody comes on the table to open up any bottlenecks that you see. After that, every other system is exactly the same thing. You get a consistent experience. The system is deployed the same way, so you'll not be experiencing the same experience that you have in the past. You say, okay, I'm seeing this issue in production, but I'm not seeing in the QA because the system was built by the 2 different people or 2 different time steps or something like that, right? You get that consistency. That's, I think, biggest advantage for me is deployment for sure. That's good, that's given, but it's the consistency that this kind of deployment brings in, right?
I know we're running up on the time. I know another group is coming in.
Okay.
But if there's something else that you would like to show, but I know AWS does have a booth in the expo, so definitely stop by and.
So even this one finished. I'm now my server is now running on a 12 terabyte instance now. So yeah, it's probably like
there you go.
enough, right?
Thanks, Naresh.
Yep.
Thank you, everyone.
Thank you, man.